This is Josh White with JW Math Tutoring. In this video, I'm going to go through the 6 hardest problems from the April 2024 ACT Math Test Form Z13. So let's go ahead and take a look.
But life is a dream that calculus could never predict.
Just before I begin this video, going through these 6 hardest ACT problems from this test, I just want to mention a couple things. First, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, the reason I'm only highlighting 6 problems from this test is because I've gotten hit with copyright strikes from the ACT when I published full reviews of completed official tests. So that's the reason why you only see 6 problems instead of the full 60, which I would love to do, full videos on. Lastly, if you're looking for more ACT practice work, please check out my Improve Your ACT Math Score course. You can find it on Udemy. You can find it also on Teachable. There are direct links to both courses in the description of this video below. And basically, this is a comprehensive overview of the math section on the ACT. It covers your common topics in algebra and geometry and probability and statistics, in addition to strategies like back solving, picking numbers, process of elimination, estimation, drawing a picture, essentially in order to help you solve problems as quickly as possible. And it also includes an entire module on using the TI-84 graphing calculator to solve problems as well. Basically, it features over 10 hours of instructional video along those 5 different modules. So please do check that out. Anyways, here are the solutions to these 6 hardest problems. All right, taking a look now at problem number 41. So this is actually a fairly tricky question, and honestly, in my opinion, one of the trickiest questions on the test to figure out. Because basically what's going on here is you have something happening every 35 callers, and you have something else happening every 50 callers, and you have to figure out how many people of these get both, basically are a 35th caller and an every 50th caller in the first 1,000 people. So if you start to think about it, basically it's like, okay, the 35th caller, then the 70th, then the 105th, then the 140th, then the 175th, blah, 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 counting up. These are the people that get the t-shirts. Then you also have the tickets, and they, this one would go 50, 100, 150, 200, 250, 300, blah, blah, blah. And you could list all these out and seeing where you get matches, up to 1,000, but that's going to take way too long. So instead, what you have to notice or what you have to see is that the numbers that are going to be in both lists, the callers that are going to be both a 35th caller and a 50th caller, are going basically to be multiples of both of those numbers. So essentially what we're looking for here is least common multiples of 35 and 50. So we can just go to the calculator to do that. We can go to clears off the math menu, and then we can go to num, and we can go down here to number 8 LCM, and just put in 35 and 50. Delete that. Okay, so we get 350. So what this means is every 350 callers, we're going to have a person who wins both a t-shirt and a concert ticket. So now, really what you're going to do is you're going to make a new list, and you're going to see, okay, every 350 callers. So that would mean the 350th caller, the 700th caller, and now you would, if you add 350, notice it goes up to 1050, but there's only 1,000 people calling. So therefore, there are only going to be two callers, the 350th and the 700th, that get both a t-shirt and a concert ticket. Because these are the only two numbers starting at 1 going to 1,000 that basically divide evenly by 35 and by 50. So the correct answer to this problem is letter A, 2. Top of the next page, I want to take a look at question 43 here, and I'm going to show you two different ways to solve it. The first way is actually going to be much quicker, much simpler. The second way is going to be a little bit longer, a little more work, but they both get you the correct answer. So everything they've given you is labeled here. Okay, so here's the first way. This is the much quicker way, but maybe not as intuitive. Notice that here we have a 60-degree angle, angle ADC. Therefore, this angle right here must be 120 degrees because these basically form a linear pair, or in other words, they form a straight line, and two angles that form a straight line are supplementary. Now, look at triangle ADB here. Okay, not a right triangle, obviously, but notice that if we add all the angles up, 120 plus 30 plus whatever x has to add up to 180. Therefore, this angle up here has to equal 30 degrees. That key fact right there is what makes this solution basically so quick and so simple. So now what I notice is that in this triangle ADB, I have two congruent angles. So across from those congruent angles, I have a pair of congruent sides. So this side is congruent to this side. That means this angle or side right here, AD, is 100. So now if you look at the right triangle on the left, right here, okay, now we have up here a 30, 60, 90 triangle. Again, we know this is 90, we know this is 60, so this has to be 30. The hypotenuse in this 30, 60, 90 is 100. Therefore, the short leg, the side across from the 30, will be the hypotenuse divided by 2, or half of the hypotenuse. That means that CD has to be 50. Now, to find AC, you could technically use Pythagorean theorem, but if you already know the 30, 60, 90 right, 30, 60, 90 right triangle rules, and you use that to get from 100 down to 50, then you should know that the long leg, AC, side across from the 60-degree angle, is just going to be the short leg times root 3. So the correct answer for this problem will be letter D, root 50 root 3. Again, that's the short, kind of quicker method. Here is now the longer approach or longer method. So let me just clear all this stuff out. So now an alternate way you could do this is you could basically define this to be x. Okay, and then what you could do is you could say that this whole side here is now just going to be x plus, or 100 plus x. Doesn't matter which order you put them in. And now I'm going to look at the overall large triangle, okay, which is also still a 30, 60, 90 right triangle. So in other words, I'm looking at ACB here. So this side right here is technically across from this angle up here, which will be 60 degrees. Again, 90 and 30, 120, subtract that from 180, this has to be 60. That means this side right here is the long leg. To get the short leg, we then take that side and we divide it by square root 3. So AC is just going to equal the long leg 100 plus x divided by root 3. Now, what we do is we go to the small triangle just on the left, ADC. Let me just get rid of this. So now again, let me switch colors here. Okay, so now just looking at this triangle right here, okay, this is 30. This is obviously given as 60. This is, okay. So 30 sorry, the CD, which is I labeled X, is across from the short leg, which is 30. Okay? Therefore, AC, which is the long leg, is equal to the short leg times root 3. Okay, so this is another expression for side AC in terms of X that I get from only looking at, again, this is looking at the small triangle, the small right triangle, excuse me, and this is looking at the large, right triangle. So now you can set these two equal and solve for X. So we just set this equal to X root 3, multiplying both sides by root 3. That's going to leave us 100 plus X equals 3X, and then you get 100 equals 2X, so X just equals 50. Now, of course, we want to know what AC is, so remember we set up here AC is X root 3, so that just means it is 50 root 3. So we get the same answer. It's more work. I think it's also more complicated to understand. But if you don't recognize that these two sides must be congruent, this is an alternate approach you can take to solve this problem. All right, let's look at 45 now at the bottom of the page here. So we have in an algebra class juniors and seniors, and we know the ratio of them is 3 to 1, basically. So we also know the percentage of each of these different groups, classes, that passed this test, and they want to know what percentage of students enrolled in both did not pass the test. So the way that I approach this, what I think is the easiest way to do this, is to use picking numbers. And so I said there are 100 total students in the class. The reason I chose that because 100 typically good, easy number to start with, but also because 100 actually divides up evenly. So if you notice here, there's 3 juniors like for every 1 senior. So that means out of 4 students, you have 3 juniors and 1 senior. So because 100 divides by 4 evenly, it also makes this a good number. So it's like if you divide 100 by 4, right, that comes out to 25. So like one part of that, which is what we get when we divide 100 by 4, one part is 25. So that means it's going to be going to have 25, not juniors, 25 seniors, and then 3 times that for 75 juniors. 75 plus 25 adds up to 100, so it meets all the conditions of the problem so far. Okay, so now what we can do is we can just take 80% of the juniors, 80% of 75, and we can also take 70% of the seniors. We can go ahead, just multiply those together. That will give us the number of students that pass the test. So 77.5% of students overall pass the test. I know it doesn't make sense because you can't have like 0.5% of a student, but just ignore that for right now. So if we want this percent of students that did not pass, it's just going to be basically 100 minus that. In other words, you either passed or you didn't pass, and together they have to add up to 100 students. So or basically 100%. So if we just subtract this, we are just going to get 22.5. So what is the percent of students enrolled that did not pass? Well, it's a 22.5%. All right, let's next take a look at question number 53. So here we have this statement inequality, I guess you could call it. And so you want to know for what values of B is this thing going to be true? So I would probably approach this just by going through. There's two ways you could do this. There's kind of the theoretical way, which is to just solve this for B. So I'll show that first, and then after that, I'll just go through the answer choices and show you why, checking them, that a bunch of them are wrong and incorrect, and therefore, we can cross them out. So the theoretical way basically says factor a B out of here, factor a 6 out of here on the bottom because they are common factors. Then the C minus D expressions will cancel. So you get B over 6 is less than 0, multiply both sides by 6. What do you get if you solve this for B? Well, just B is less than 0. That corresponds to all negative, real numbers. So the correct answer here is letter E. Now, that might not be obvious to you in terms of like, just going ahead and solving whatever B, and that's fine. If that's not obvious, if that's not something that pops out to you or makes sense, like don't worry about that. Here's how you could get this by basically going through the answer choices. So I would plug in starting with the answer choice A, plug in 6 for B. So notice you get 6C minus 6D over 6C minus 6D. These two expressions are identical. Therefore, they cancel out and you're just left with 1. Is 1 less than 0? No. Also notice, as we're going through this, you could go to the calculator and you could pick numbers for C and D. Okay? Like, just let C equal 1 and D equal, I don't know, 2. Or C equal 2 and D equal 1. It doesn't really matter. But you could plug those values in and then you could go ahead and just calculate them out and see, do I get a negative value on the calculator? And because you can just copy paste the next line down to the next line for the next answer choice, it's not actually going to take that long. So now if you plugged in, so what's going to happen is for these first three answer choices, like they're all going to follow the same pattern, which is you factor out, like this number you're plugging in, you factor it out, and then you get basically C minus D on top and C minus D on bottom, and they cancel out. And then here we get 1/6 over 6, which is technically 1 over 36. That is not negative, it is still positive, so this ends up not being equal. Okay, so now what happens is when you go to check letter C, actually, let me switch colors, just don't have to erase and rewrite the whole thing. Okay, so if you plug in negative 1/6, notice it makes this negative and it's going to make this positive. And then what's going to happen is, in order to make these two expressions equal, you have to factor out a negative 1/6 in order to get C minus D on the top. And then you can cancel them out. And now we get negative 1/36. And that is less than 0. So this one checks. So we'll keep it for now. Notice if we went to D, all positive numbers. Well, we already checked A and 6 doesn't work. And we already checked B, 1/6 doesn't work. Those are positive numbers. So the answer can't be D. Like that's basically eliminated because both A, either A doesn't work and B doesn't work. So now all you would have to do for E is check another negative number. And you could just make it, whatever. You could just make it -1. So like, if I go back here, if I plug in -1, it's going to look like this. -1C plus 1D, and then you factor out a -1, so then it flips and becomes C minus D. The C minus D's cancel. Now you get -1/6. Is that less than 0? Yes, it is. So the correct answer again for this one is going to be E. And again, you could just type this in, and I'll just show you real quick here on the calculator. I think it will be quicker, honestly, just to do it horizontally. So it's like if you were starting with A, right? I just do like 6 times, let's say C is 2, minus 6 times 1, parentheses, by, and then on the bottom, 6 times 2 minus 6 times 1. Okay, and again, there we get +1. So when I was checking answer choice A, that's what I got. 1 is not less than 0. And then see again here, you could just copy this down. And now, yeah, it's going to take a little time to change all of these 6s to now 1 6 because you're going to have to insert a 1 and insert a 1 and everything to check that. But it's not that bad if you actually want to use real numbers and everything and check it, on the calculator as well. Next, let's take a look at problem number 56 at the bottom of the page here. So we know that event A has basically 6 items in it, and event B consists of 3 items, and there's no overlap between them. So event C, which is the union of A and B, means basically everything in A or B. So in other words, you would add together the 6 and the 3 to make 9 total possibilities, 9 total events in, event capital C. And then D is the intersection of A and B. So since there's nothing in common, the intersection is just going to be 0. So now we can go ahead and we can get everything lined up. So let's see here. Notice the absolute, this absolute value notation or whatever here, that's just basically equal to the numbers of events we have for each of these things. So we see that starting off, D is the smallest because you have 0, and then B is going to be less than B, which has 3, and then less than A, which has 6, and less than C, which has 9. So again, 0, 3, 6, 9. So now looking at our answer choices, looks like the correct answer for this one should be letter J. Again, terms you need to know, things you need to be aware of, the union of two sets, that just is basically like the combination of the two sets, and of course you don't double count any overlapping items. Um, so basically add them together, and then if there's overlaps, you only list them once. And of course the intersection of two sets. So those are only the values or items or events or whatever that are in common between both of the sets, i.e. appear in one set and also appear in another set. And again, that is 0 for this one because they tell you that the 3 simple events in event capital B are not in event capital A. All right, next let's look at problem number 58 here. So this one is, I guess, kind of a weird question. It's just property of number, kind of trial and error type problem. I mean, you could use a calculator to help you out with it a little bit, but basically they are asking here how many integers that you would plug in here and evaluate this and then get a positive prime number as your answer. So first of all, a couple things to notice, and you can also see this if you graph it out. Basically, first of all, to get a positive number, you're going to have to plug in x's greater than 4 or x's less than 1. If you plug in anything between 1 and 4, it's going to be negative because this parenthesis would be negative, but this parenthesis would be positive. For example, if you plugged in 2, 2 minus 1 is 1, but 2 minus 4 is negative 2, 1 times negative 2, so on. Okay, so we're only looking at numbers basically greater than 4, less than 1. So notice if we start here, just going through and like plugging in some possible values, notice you plug in 5, okay? You get 5 minus 1 is 4, and then times 1 is just 4. So notice, not a prime number, okay? When you plug in 6, 6 minus 1 is 5, and then 6 minus 4 is 2, 5 times 2 is going to be 10. Then notice when you plug in 7, 7 minus 1 is 6, 7 minus 4 is 3, 6 times 3 is 18. When you plug in 8, 8 minus 1 is 7, 8 minus 4 is 4, 7 times 4, 28. Okay, so notice so far none of these are prime numbers. And hopefully you've started to see basically that the answer is going to be F. It's going to be 0. All right, and the reason is because, I don't know why the minus sign just disappeared there. The reason is because basically you are going to get, when you take a number, an integer, and you plug it in to each of these parentheses, basically each of these factors, okay, you're going to end up with two different numbers. So you're going to multiply two different numbers together in order to make a new number. Therefore, the new number is essentially guaranteed to not be prime because a prime number is a number that only has two factors, one and itself. So if you end up with two numbers that are not one and you multiply them together, then the result is automatically not a prime number because you're multiplying 2 and 5, or you're multiplying 6 and 3, or 7 and 4, or whatever, keep going. So that number, the number you get, is not going to be a prime number because in addition to the number and 1 as factors, it also has the two numbers that you just multiplied in order to make the number. Now, really, the only one you have to check is like 5 because there you do get 1 times something, but it happens to work out that 4 is not a prime number. So if this was like, say, x minus, I guess we changed it to x minus 2, and then you plugged in 5, then you would get 5 minus 4 is 1, and 5 minus 2 is 3. 3 times 1 is 3. Like, then it looks like there would be 1 value, that gives you one x value that gives you a positive prime number. But that's not the case here. And you could also try it for the values less than 1. And so notice if you plug in 0, for example, you get 0 minus 1, -1, and then 0 minus 4, -4. -1 and -4 is positive 4. So, and then if you plug in -1, -1 minus 1, -2, -1 minus 4, -5, -2 times -5, 10. Notice I'm getting the exact same, sorry, this should be -1 up here. I'm getting the exact same y values here, regardless of regardless of what x value I plug in, and that's because this is a quadratic function which is symmetric. So we don't need to go through and keep checking the rest of these values. Okay, they're all going to be the same. This is going to be -2, and this is -3 is going to correspond to 8 and everything, because that's how a quadratic function works. Values that are on opposite sides of the vertex horizontally at the same distance apart are going to have the same y value. So the answer to this problem is 0. Again, the reason is because, like, once you check 0 and 5 and you see that plugging that in does not give a prime number, every value above that is going to have you multiplying two numbers that are not 1, which means that the result cannot be prime. Okay? Because the result you get will have 1 and the number in addition to those two numbers you just multiplied. Again, that's the reason behind it. And secondly, the reason we had to check only from 5, up through the positives and 0 down into the negatives is because we need it to be positive. All right? And between 1 and 4, this quadratic function is basically negative. And of course, it's 0 at x equals 1 and 0 at x equals 4. If you enjoyed this video, if you have any questions or comments on these problems, please do leave them below. Otherwise, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. And of course, as I mentioned earlier, check out my Improve Your ACT Math Score course if you're looking for more resources to help raise that ACT math score of yours.